Yeah, here on the firewalls we are going to configure an IPsec. Okay, this is our simple topology. Our two firewalls are connected directly to each other, and we have one Windows machine here and another Windows machine connect to one other firewall. Okay, if you want to configure an IPsec, there are no such prerequisites that needs to be checked. Okay, if you have a firewall with good connection, that should be fine. And before doing the lab, what we have to do is we have to do an basic configurations. What are the basic configurations that we have done in the first lab that needs to be done on the every. I am telling you this on every lab. Okay, the basic configuration should must and should, because we have to enable all the interfaces, we have to create the zone, right? So on I'm proceeding, I have already configured on this firewall, but I haven't configured, I have newly deployed this machine, right? I need to configure. Okay, before going that, we can configure one by one. Okay, I will configure it fast, because you already know how to configure this, right? So first we need to configure a zones. I'm configuring one zone with inside and one zone with outside. And also for this IPsec, we need one more zone called VPN. Okay, not VPN, whatever the you want that you can configure, but I am configuring it as an VPN zone, because we are creating a tunnel interface as well here. Okay, the tunnel interface should be on the VP, whatever the zone that we have created. Okay, on the interfaces, what we need to do is, what are the Ethernets that we have connected. Ethernet 1/1 for Windows machine, 1/2 for internet, 1/3 for IPsec, right? So I will enable this, and here the Ethernet should be L3, and default router I am going with a default virtual router, security zone inside, and I need to know the what is the IP address here on the other firewall. I will stop once. Okay, whatever it may be, we will configure one more. Okay, here I am going with 30.30.30.10. Okay, /24 on this interface on the Ethernet 1/1. Okay, the firewall Ethernet 1/1. I am configuring 30.10, and in the advanced tab you need to configure management profile, right? Go ahead and create a management profile. Just create with allow ping, enable the ping. Okay, that's all on this interface. And Ethernet 1/2, we have configured it for the internet, right? L3, the same virtual router, and this security zone should be outside. Okay, and IP address, get it from DHCP client. We are not configuring, because you know, right, we are already connected to this internet. We can get the IP address from there. And in the advanced tab you will have a management profile. Just go ahead and we no need to configure management profile on outside interfaces. That should be some vulnerable. Okay, don't configure management interface management on the outside interface. Okay, and this Ethernet 1/3 we need to configure. This is same L3. Go ahead and default virtual router, security zone is keep it in outside only. Okay, and this IP address we need to configure, and I am going with 192.168.10.1/24, this interface. Okay, this interface I am going with 192.168.10.1, and here if we want we can allow the ping here. And after configuring Ethernet interface, just configure one tunnel interface as well for IPsec. Here we will be having a tunnel interface. You need to mention the numbers here 1 to 9999. Okay, I'm going with an 1, and here the network profile should be none. Okay, and virtual router default, and here we need to mention security zone as VPN and allow the ping as well here. Click on OK. Okay, these are the basic configuration that we need to do. Okay, and after the basic configurations, we need to configure in policies also, right? We need to configure the policies. Just create one policy with inside, outside. This is a basic configuration before doing a lab. Create an inside one, destination is an outside, the action should be allow. Okay, click on OK. This is the basic configurations. Now we are proceeding with an IPsec configurations. What we need to do an IPsec configuration means, if you want to do an IPsec configurations, go ahead on the network tab. Here we will be having a network tab, right? See, here we will be having network profiles. In the network tab we will be having network profiles. In that network profiles we will be having IKE crypto, IPsec crypto and IKE gateway. After that IPsec tunnel. What are the we need to do is, for we have discussed about phase 1 parameters, right? If you want to configure phase 1 parameters, you have to configure in IKE crypto. Okay, click on IKE crypto. It will be, these are the default ones. If you want to create one, we will be creating one. Okay, just click on add, give the name. I am going with an TBN phase 1. Okay, I am going with TBN phase 1. These are the phase 1 parameters. Here we are configuring an haggle parameters. Okay, in the group we are going with an DH20. We have multiple groups, right? The higher the number, the security will be more. Okay, security will be more means the group 20 will be calculating an higher value. Okay, so higher the group and the more the security. Okay, here the hashing. Okay, we will be having MD5 and SHA. I am going with an MD5, and encryption we will be having DS, 3DS, AES, right? I am going with an whatever you want you can select. Everything will be doing a same operations. Okay, whatever you want you can select. I am going with an AES 256, but whatever you are selecting here, the other side also should be same. Okay, and the lifetime by default the lifetime will be in 8 hours, and you can also mention you can also go with 24 hours as well. The maximum lifetime for this IPsec phase 1 is 24 hours, but by default it will be taking an 8. That should be okay. This is all about the configuring phase 1. Okay, phase 1 parameters. We have configured phase 1 parameters. Once you configure phase 1, go with an phase 2. Just same wise you can click add. I am going with TBN phase 2. See here, by default the IPsec protocol it is taken as an ESP. Okay, if you want you can also change AH, but by default it will, if you select the AH only it will be providing an authentication, right? So if you are selecting ESP, it will be providing encryption as well. Okay, in the encryption what you have to do is you have to go with whatever you want. I am going with AES 256 CBC, and authentication. Authentication means this is a SHA. I am going with an MD5 here as well. Go with the group, higher group. Okay, and the lifetime it will be of 1 hour. Okay, I think it will be also maximum of will be having 1 hour only. Okay, will be go with that 1 hour. The phase 1 what we have is, yeah, okay. After configuring phase 1 and phase 2 parameters, we have to build up the phase 1 tunnel. Okay, if you want to build up the phase 1 tunnel, the IKE gateway where you can configure an phase 1 tunnel, you can just click on phase IKE gateway, click on add. See here the name, we got a name, right? So you can just go with a name IKE TBN phase 1. Okay, this is the phase 1 tunnel. In the versions we have two types of versions, IKE v1 and IKE v2. The IKE v1 is what are the main difference between IKE v1 and IKE v2 means, In the IKV1, whenever you are configuring IPsec tunnel, it will be providing an less bandwidth, but in IKV2 will be providing more bandwidth. But for our lab purpose, we are going with an IKV1 only, okay? And the address type should be IPv4 or IPv6. We have configured an interface, okay? Whatever the interface that we are connected, whatever the interface that we are connected to the other side, we will be calling that interface in the phase 1, okay? Here we need to take the interface. If you drag down that interface, it will show the interface. Whatever the interface that connected to the other side, you need to select here, okay? The local IP address. This IPv4 address referring the local IP address, okay? Whether it is IPv4, if you have configured IPv4, you can select the local address here. It will obviously show here once you configure. We have configured 10.1, right? It will take care, okay? And the peer address type. Peer address type should be IP or FQDN or dynamic. Dynamic means if you are getting IP address from the DHCP server, not the local IP, the peer IP, okay? This peer IP, if you are getting an IP that you have configured here on Ethernet 1/3, if you are getting it from the DHCP server, you can select it as a dynamic, okay? If you are using not an IP address, if you are using some FQDNs like www.tbnnetworks.in, if you are using that, you need to mention the FQDN address here, okay? But I am not using FQDN, I am going with an static IP only. So I will configure 192.168.10.2 here, okay? Because we have directly connected, right? This should be in the same subnet. We are here in this case, we are directly connected. In the real time, that should not be a directly connected, because one site is in Hyderabad and one site in Bangalore, right? There should not be a direct connection. There may be getting an IP address from the ISP, or there is configuring statically. Whatever the IP address that are configured on the interface, that you are going to configure an IPsec tunnel, you have mentioned here. In this case, I have configured, I have connected. నేను ఇక్కడ డైరెక్ట్గా కనెక్ట్ చేశాను కాబట్టి నేను సేమ్ సబ్నెట్లో తీసేసుకుంటాను, ఓకే? ఇక్కడ 10.1 అనుకున్నా, పీర్ వచ్చేసి 10.2, ఓకే? Here what actual authentication here, okay? The authentication we have discussed about pre-shared key and certificate, right? If you are using pre-shared key, you can manually configure here whatever you want, okay? If you want anything like 1 2 3 4 5 6 7 8, okay? I am configuring 1 2 3 4 5 6 7 8, and I am also confirming with the same pre-shared key 1 2 3 4 5 6 7 8. If you want anything, you can configure in the pre-shared key, okay? It is a easy way. If you are selecting a certificate, you need to get a, if you want, you can create a certificate in the firewall as well. And otherwise, if you don't want the certificate in the local, you have known any third party certificate agents, you can get it from there, okay? But pre-shared key, using a pre-shared key an easy method, because whatever we want we can configure here, okay? Here in the local identification, we are going with the none. If you want, you can configure the same IP addresses here, local 192.168.10.1 and peer identification 10.2, okay? That's all on this in this general tab. And go ahead on the advanced option. We'll be having exchange modes. Exchange mode means we will be discussing about phase 1 modes, right? Whether it is a main mode or aggressive mode, okay? If you we are creating an sub IPsec between site to site, right? If you go with an auto, it will be by default it will be selecting an main mode only, okay? Because between site to site, obviously it will go with an main mode. No, I don't want main mode, I want to go with an aggressive mode, we can also go, but I am selecting as an auto. Let's see how it exchange the information, okay? Here IK crypto profile, whatever the IK crypto that we have configured here, we have to call in this, because we need to exchange that parameters in the phase 1, right? Once you configure, that is not necessary, you have to call here as well, okay? Whatever the configuration that you have configured, TBN phase 1, you have to call here, okay? And we have dead peer detection, okay? Dead peer detection means, for suppose these two firewalls are up and connected to the IPsec tunnel, okay? For suppose for any reason this firewall went down, okay? What this firewall do? This firewall will wait for some time, okay? And wait for some time means whatever the dead peer detection we have configured, 5 intervals. 5 intervals means this is for 5 seconds. interval is 5 seconds and retry 5 times. So means this 5 into 5 25 seconds. Okay, it will wait for 5 seconds and it will try to wait till 5 retries. Okay, 5 into 5 25 seconds, it will wait for 25 seconds and it will comes to the conclusion that our peer is dead and it will terminate the IPsec tunnels. Okay, that's how the dead peer detection works here. And here we have two common options. One is in passive mode, one is in NAT transversal. When we are using passive mode, when we are using NAT transversal means, if I told you right, if other peer IP address is dynamic, means we don't know what is the IP address, right? If it is dynamic, we don't know what is the IP address configured here. So if one side is static, we have configured and static, then other side is dynamic, we have to go with an passive mode. Okay, what happen when you enable passive mode means, you have to enable passive mode where you have configured a static IP. Okay, see here on this firewall I have configured a static IP and on this firewall we have a dynamic IP. So you have to enable the static, you have to enable the passive mode on this firewall because we are using a static IP. Whenever you are enable the passive mode, this firewall will always be acting as a responder. Okay, it won't initiate a traffic, it will always acting as a responder. We have a roles here. The traffic, the firewall who is sending a traffic, that will be calling as an initiator. The firewall who is receiving the traffic will call as a responder. Okay, once you enable the passive mode, the firewall will be always be acting as a responder. Okay, because if you want to initiate the traffic, we have to know the IP address of this, but it is a dynamic, we don't know IP address of this. So that's why we are enabling the IPsec passive mode here, so that it will always acting as a responder and this will initiate the traffic. So that is an easy way. That's why we have an option here, passive mode. And when we are using a NAT transversal, okay, when we are using NAT transversal means, for suppose if you have any device in between here, okay, and you have configured an NAT. If you have any device in between IPsec peers that is supporting a NAT, you have to enable the NAT traversal. Okay, if you enable the NAT traversal, why we need to enable NAT transversal means, if you have any device, NAT device in between, this NAT device working on an L4, but our IPsec protocol will be working on L3, right? So there is one compatibility between L3 and L4. Okay, so that is the reason it if NAT device in between our IPsec peers and IPsec firewalls, our L3 traffic won't be passed through the L4. Okay, L4 device. So in order to transfer our L3 traffic through the NAT device, we need to enable the NAT traversal. Okay, if you have any, when we are using NAT traversal means, whenever we have NAT device in between our IPsec peers, we need to enable the NAT traversal. That is the reason these two options will be there. We have to use in a situation wise, but in this case we are not using these two because we are manually configuring on both sides and also there is no NAT device. If there is a NAT device, enable NAT traversal. If you are using dynamic on any of the firewall, you can use an passive mode where you have a static IP configured. Okay, understood, right? Passive mode and NAT traversal, and apart from that nothing we can do. These are the general configuration. Okay, click on OK and our IPsec phase 1 configuration is done. Once IPsec configuration is done, go with on the top we have an IPsec tunnel. You need to configure an phase 2 tunnel as well. Okay, here the configuration is simple. Here just give the IPsec. Okay, TBN IPsec phase 2. Okay, this is a phase 2. We have already created tunnel interface, right? Okay, just go with the tunnel interface and the same the type auto key and address is an IPv4. See here, IKE gateway, whatever the phase 1, because once the phase 1 is formed, the phase 2 parameters will be flown in the phase 1, right? So we need to call the phase 1. Okay, I have configured an IKE TBN phase 1, right? I am calling here, And to exchange the phase 2 parameters, we have configured an IPsec crypto. We have already configured an parameters, but we haven't called here. Okay, so we need to call that phase 2 parameters as well here. Okay, here in the these are the things that you need to configure in a general tab, and after that you need to go with the proxy IDs. These proxy IDs we need to, when we use these proxy IDs means whenever you are forming an IPsec tunnel between two different vendors. Okay, two different vendors means one side is Palo Alto, one side is Cisco ACA, one side is Palo Alto, one side is Checkpoint, and whether it is an FortiGate, whether it is an Zscaler. If you are forming an IPsec tunnel between two different vendors, one side is Palo Alto, the other side is different vendor. So in that case, you need to use an proxy IDs, because why we are using proxy IDs here means this Palo Alto firewall is a route-based VPNs. Okay, route-based VPN means the firewall will be working on the routes. If you want to route the traffic with the VPNs, through the VPNs, we need to create a routes. But other firewalls, like other firewalls in the sense Cisco ASA or Checkpoint or FortiGate, they are policy based, because they need policies. They have to create a policies to route the traffic, but these firewalls are the route based VPNs, right? That's why we need to configure proxy IDs, so that we need to include the remote sites and local sites. Remote site means here we are creating a proxy ID, give the proxy ID whatever you want, and in the local we need to give this subnet. Okay, this whatever the subnet we have this in the local. See here, this is our Palo Alto. For let's suppose this is our not Palo Alto, any other vendor Checkpoint. So in the local, what you have to do, you have to give a local subnet, and in the remote you have to give the remote subnet. Okay, here in the local you have to give the local subnet. Let's suppose we have configured 30.30.30.0/24 that you have to give here, and the remote subnet you have to configure in the protocol. If you go with any protocol, whether it is an TCP or UDP or any protocol, you can go with any. That's where you can configure proxy IDs. Okay, when we configure proxy IDs, whenever we are forming an IPsec tunnel between two different vendors, one side is Palo Alto, one side is other vendor. So that's why we are configuring proxy IDs. Why means these Palo Alto firewalls are route based VPNs and other firewalls are policy based VPNs. That is the reason. Okay, this is how you can configure an IPsec tunnel. And once you configure IPsec tunnel, you can see the status here. One is an IKE info and other one is an tunnel info. Okay, so the next thing that you need to configure is, after configuring an IPsec tunnel, we need to create a static route, because I told you, right, for firewalls, these Palo Alto firewalls are route based. So if you want to send the traffic through the IPsec tunnel, we need to create an routes. Okay, I want to know the subnet of the other side. I think I have missed this. I will check the subnet on this once. I think we have used 10.subnet. Let me confirm once. So we need to create a static route on this firewall. Okay, on the we need to create a static route on this firewall to reach the destination, right? To reach this destination, we need to tell this firewall, if you need to reach this destination, you have to flow through this tunnel, right? We need to create a static route. We need to tell the firewall that you need to flow through the tunnel. That's why we are creating a static route. So I'm just logging in this PC to confirm the what is the IP subnet that we have configured here. I can configure, I can see from the firewall as well, but there is some glitch in this cloud lab. If I open this firewall, it will be logging out. Okay, already we can take one firewall at a time. That's why I'm going on the lab Windows mission. I will check from here only, right? IP config. Yes, we are using an 10.network. Okay, here this is our 30.network and this is a 10.network, and I'm configuring IPsec here, right? On this firewall, what I need to do is I need to create an static route. How we can create a static route means here in the network tab we'll have an virtual router. I told you, right? Whenever you are configuring our interface as an L3, there is an virtual router where it will be acting as an router. Okay, the firewall will act as a router in this case, and whatever the routes that you want to configure, we have already called all the interfaces in this default VR virtual router. You need to configure a static route here itself. Okay, if you click on the default, it will show static redistribution, RIP, OSPF, BGP. Okay, we can configure routes here. I'm going with an static route, so I have to create a static route. Click on the static route, just click on add here, name the name whatever you want. I am going with a destination 10.10.10.0 network, and you have to mention the destination network. Okay, what is the destination? 10.10.10.0/24. The interface, whatever the interface that you want, you have to go with the tunnel interface, not go with the Ethernet 1/3. Go with the tunnel interface because we are creating a tunnel for sending a traffic, right? So go with an tunnel interface. This is for the phase 2 because Ethernet 1/3 is using for the phase 1 and this tunnel interface is using for the phase 2. Our actual traffic will be flowing through this phase 2 only, right? So we are telling the firewall whenever the traffic, actual traffic coming through this firewall, you can just send through this tunnel. Okay, if you are selecting an tunnel interface, the next stop should be none. Okay, because we know if if tunnel is formed, the tunnel is forming between these tunnels, these firewalls. Once once the traffic reaches this tunnel, it will obviously ends here. Okay, because the tunnel will be formed between these. If you are using Ethernet interfaces, we have to mention the next stop obviously. Okay, that is the one thing that you need to remember. If you are using tunnel interface, the next stop should be none. These are the things that you need to configure. Okay, give the name, give the destination, interface, next stop. That's it. Our static route completed. And apart from this, you need to configure in policies as well. Okay, because here we have an inside zone and this is our VPN zone, right? Whatever the traffic coming from VPN to inside and whatever the traffic going from inside to VPN, we have to allow that. Okay, for that we need to create an policies. Okay, let's create inside to VPN. Okay, one policy. Let's go with inside. Destination zone is VPN. Application should be any, service URL should be go with anything, and action should be allow. Okay, create this one and again go with the another one, VPN to inside. One is from inside to VPN and other policy is from VPN to inside. Okay, go with VPN and destination zone as inside and action should be allow. These are the two policies that you need to create. Apart from that, everything should be okay. We have configured an IPsec. We have already configured static route and also the policies. Okay, this will be done. Just go ahead and commit this configuration. Just commit this. Okay, it will commit. Meanwhile, we'll be configuring on this firewall. You are getting right whatever I am configuring, or do you have any confusion here? See here, the same thing you need to configure on this firewall as well. Before that, we need to I already have configured these Ethernets. but I need to configure an Ethernet 1/3. So Ethernet 1/3, I'm configuring this Ethernet 1/3 as an L3, and we have to configure an throw this down. The virtual router should be a default one, and security zone I'm going with an outside. Okay, and the IP address I'm going to configure as static. So here I'm configuring this on this interface, right? I'm going to configure on the same subnet, so that that will be reflector here. 192.168.10.2/24. I have configured 10.1 other side. I am configuring 10.2 here, and here on the advanced tab, go ahead on the management file and just allow the ping. That is fine. Okay, and after that you need to configure a tunnel interface as well. I think I have already had a tunnel interface, but maybe this is using for different purpose. I will also use an other tunnel 2. Here the tunnels, whatever the tunnels that we are configuring here, one side I have configured tunnel 1 and other side we have configured tunnel 2, right? That is not an mandatory, the tunnel should be on the same on the both sides. Okay, we have configured whatever we want, but we have to mention whatever we are configuring on the IPsec, we are calling that, right? So that should not be an problem. Okay, and everything is fine. We have configured Ethernet, we have configured tunnel interface, we already have zones. Okay, let's go ahead and configure an IPsec. Okay, the IPsec configuration should be, the name should be whatever we want. Okay, but the parameters, okay, that we are configuring should be match. Here I am going with MD5 and encryption 256 CBC, and lifetime is 8 hours. And on the IPsec crypto, I am going with TBN phase 2. Here the encryption same AES 256 CBC, and authentication MD5, and group 20, lifetime is 1 hour. And IKE gateway for phase 1 on this. Okay, I am going with TBN IKE phase 1 tunnel, and the version should match. Okay, the version on the other side IKE when I use, here also I am using the same. The interface, whatever the interface that we have connected, we have to see here as well. And Ethernet 1/3 we are using that, and local IP 10.2, and the peer IP 192.168.10.1. Okay, we have to match this. Okay, whatever the IP address that we have configured out that side, we have to configure the same peer IP. Okay, and the pre-shared key should match. Okay, 1 2 3 4 5 6 7 8, whatever the pre-shared key that we have configured there, that should be matched here as well. We have to configure the same. Okay, and we haven't configured any local and peer identification, that should not be an issue. See here also we have passive mode and NAT transversal, and exchanging mode is also auto. And IK crypto, we need to call the IK crypto here, TBN phase 1, and deadbeat detection interval is also same. Click on OK, and IK next IPsec tunnel, right? And IPsec tunnels, go ahead and add IPsec tunnel here. Give the name TBN IPsec phase 2. Here the tunnel interface that you need to call. Okay, tunnel interface 2 that we have configured. IKE gateway, what is IKE gateway that we have configured? TBN IKE phase 1, and IPsec crypto phase 2, whatever we have configured here. Okay, should click on OK, that should be fine. Okay, after that what we need to do, we need to configure a virtual router, right? So on the default one, click on the default static route. Static route for, we are configuring static route on this interface, right, on this firewall. So you have to create a static route for this destination 30.30.30.0/24. Create that, I am giving the name destination 30.30.30.0 and the destination subnet 30.30.30.0/24. Okay. The tunnel interface that you need to mention here, the tunnel interface, whatever the interface, the next hop should be none. Okay. Click on OK here. Our static route is created. Okay. And after the static route, what we need to do, we need to configure and policies, right? We can go ahead and create two policies here. Here, see here on the other firewall, we have created two policies, right? I will show you we can be use one policy as well. Okay, just give the name inside to VPN. Here we can call that two policies in two zones in one policy only. Okay, we can also configure in the same way so that it will be act. What we can do is call inside first and also the VPN. Okay, and in the destination call the VPN and also the inside. Okay, this will also work in the same way. Okay, instead of creating two policies, we can also create one policy. Whatever the traffic coming from inside zone and it is going from VPN, it will be hitting this policy, and whatever the traffic coming from, whatever the traffic come inside to inside also, it will match this policy. Whatever the traffic coming from VPN to VPN also, it match. Instead of creating two policies, we can also go with an one policy as well. By creating like this, we will be calling it as an universal rule, and action should be allow. Okay, and we have this inside VPN, right? We have configured for this, and after that we have already created everything. We have created IPsec, static route, policies. Everything is done, right? We can go ahead and commit this configuration. And apart from that, we need to configure an IP address here as well, right? So on this PC, we have already had an IP on this, and we want to configure an IP here in this 30 dot network, right? This is test 1 2 3. Let me check if you have any IP config. We don't have any IP. We can configure an IP. You know, right? In the PCs, we can configure IP in two different ways. One is creating a DHCP on this firewall, and we can configure also with the manually. Okay. On this interface, what in IP address that we have configured, it is 30.30.30.10, right? Here on this, we can configure IP address properties. Use this following IP address. I need to confirm. Okay, network. What is the interface? Ethernet 1/1, and we have configured 30.10. We will going with any other IP. Okay. The same subnet we will go with 30.30.30.30.2. Subnet mask should be 255.255.255.0. Default gateway 30.30.30.10, and we'll go with the preferred DNS 8.8.8.8. Okay, that's fine, and close this. See here, let me try to see the configuration. The commit is successful, right? Oh, commit is failed. Something is done here. Oh, peer address is dynamic. We haven't changed. See here, the commit that we have made got failed because it is showing the reason IKEv1 gateway peer gateway ID must be defined when peer address is dynamic. I think we haven't changed we haven't changed that to the sorry, we haven't changed it to the IP. That's the reason it got failed. 192.168.10.2. Okay, in the verification, whenever I am demonstrating you with the passive mode, I made it as a dynamic and I haven't changed it back. That's the reason the commit got failed. Because if you are using a dynamic, there is it is telling that we need to configure an ID. Here it is a dynamic 192.168.10.2. Okay, click on OK. We got. Just go ahead and commit. Here in this case, the commit is successful. I think so. Let's wait for commit. It will complete. Hey. This is a one problem with my cloud lab. Whenever I am logging in one firewall, the other firewall will automatically logging out. You can see here if commit is if you want to see any commit jobs or any other tasks, you can see from the task bar. Okay, we have a task menu. Is it is someone took the access? No. Let me refresh this. Oh, I lost the access. Why I lost the access? One 192.168.show show interface management. Oh my god, IP got changed. Why? In between, how it got changed? 111. Just a minute, guys. Let me log in this firewall. It should not be the case. Okay, once the firewall got an IP before, it is 105, but it got changed to 111. Don't know how. Something is happened on. You can also check from here. Okay, there is a command called show jobs all. You can see whether the commit is completed or not. See here, the commit was finished now. Okay, there is a command called show jobs all. You can see from there as well. You can close this, and what we can do is we can check the IPsec tunnel. See here, the IPsec tunnels not came up because I told you, right, in the initial configuration, if you want to send if you want to build up the tunnels and if you want to bring the tunnels up, there is the traffic should be flown through this tunnel. Okay, unless traffic is flown, the tunnels won't come up. If you want to see the tunnels, here we are seeing the red lights, right? If you want to see it as a green, we want to ping the traffic. Okay, we want to send the traffic through the tunnel. Okay, for that what I will do is I will be pinging from this 10.10 to 30.30.30.2. Okay, let me try if we are able to ping. ping 30.30.30.2. What I am doing is from this PC, because I have this firewall access now, I lost the access. I have to change the settings. Okay, I have access to this firewall, but this firewall is up, but we don't have management access. That's it. Whatever the traffic flowing, it will allow. See here, I am accessing this firewall, and from this PC, I am initiating the traffic to this PC. Okay, this is 10.10 network, and this is 30. Network. This PC IP is 30.2, right? I am pinging from this PC to this PC. Let's see if you are able to ping. See here, we are not able to. Yeah, we got an access. Okay. Yeah, we got a reachability. If you are able to ping, your IPsec tunnels also should come up. Okay, you are able to ping now from this PC. You have a reachability. How the traffic comes? This ping traffic will come from this Windows machine to this firewall. Once traffic leaving the firewall, what the firewall will do? It will be doing encryption, hashing, all the things it will do, and it will send the traffic through the already phase 1 tunnel will have formed, phase 2 tunnel will form. Our actual data will be flown through the phase 2. Okay, and it will reach us here. What the firewall will do means this firewall will decrypt the traffic, because here it is encrypted and here it is the traffic. Once the traffic received, the firewall will decrypt the traffic and it will check the routes if you have a route to the destination or not. Here also it will check the route. Okay, it will check the route and it will be passing through the tunnel and it will reach the this firewall. It will check the route to the, obviously it is directly connected, right? We will have a route, it will send here. And again, this is a request packet. The reply, this will generate a reply and the reply will be reaching here. What this firewall will do while sending the traffic, it will check the routes and it has to flow the tunnel, right? Before flowing, before sending out, it will be decrypting. It will be encrypting. Okay. One thing you have to note down is whenever traffic leaving the firewall will encrypt and send through the tunnel. Once the traffic reaches the firewall will decrypt the traffic and send the traffic to this Windows machine. That's how you can get. Let's see if we have the tunnels are up or not. We'll just refresh this once. See here, our phase 1 is up. This is a phase 1. IKE info is a phase 1 and tunnel info is a phase 2. If you click on this info, see here, this firewall is acting as an init. Role is an init because we have initiated the traffic from here, right? We have initiated the traffic from here and this firewall will be initiating a traffic on the tunnel. Okay, this firewall will be acting as an initiator here. And the main mode, okay, it is using a main mode and algorithms. What are the algorithms that we have used here? It will show here and created and expired. Okay, what it will showing May 1 02 and it will expires on May 1 10 because we have created a lifetime as an 8 hours. So after 8 hours, what it will do is it will be rekeying. The firewall will not keep the down IPsec phase 1 down because in the Palo Alto, what firewall will do is once this before this time expires, it will again rekeying with the same parameters. Okay, once this parameters is matches and it will get an reply. This created and expired date will change. Again, it will be changing with another 8 hours. Okay. In the same way, unless the parameter should match, this tunnel won't go down. Okay. This is how you can check on the phase 1. If you want to see on the phase 2 info also, you can see. This is a phase 2 info. This is a local IP. Okay, 10.2. This is a peer IP. And you can see here encrypted packets and decrypted packets. I will maximize this. See here encrypted packets. Encrypted packet means the firewall is sending the traffic. And if it is an decryption, the firewall is receiving the traffic. Okay. Here in this there are some troubleshooting scenarios. Okay. If you see the phase 1 tunnel is not coming up, what needs to check, and if the phase 2 tunnel is not coming up, what needs to check. But in another scenario, the phase 1 is up and the phase 2 is also up, but the traffic is not flowing. Okay, if the phase 1 tunnel is up, is phase 2 tunnel is also up and the traffic is not flowing, you need to check this encapsulation and decapsulation bytes. Okay, what it will say is encapsulation means the firewall is sending the traffic, because the firewall will encapsulate the packet and it will send. Whenever the encapsulation is done, the encapsulation byte will increase here on this firewall. Okay, and also the decapsulation. What decapsulation says? The firewall receiving the traffic. Whenever the traffic receives on the firewall through the IPsec tunnel, it will decrypt. Whenever the firewall decrypt the traffic, the decapsulation bytes increase or packets will increase. You can compare with this. Okay, and also here you can also check from the CLI as well. There is an command called show VPN flow. Okay, IPsec VPN flow name of the IPsec tunnel. Okay, we have an TBN IPsec phase 2. It will show here what is your whatever the information you are seeing here on this. Okay, whatever the information you are seeing here, you can also see on this CLI. See here what is the tunnel TBN phase 2. See here the name TBN phase 2. The type is IPsec, gateway ID, local IP. Here we are also seeing a local IP, peer IP. What is the tunnel interface? What is outer interface? Okay, and also you can see here the next thing is an here key type is an auto key. Auto key means it will automatically once the before time expires, it will be rekeying. Okay, it will auto key. And if you want to show, see here here we have an encapsulation packets, decapsulation packets, encapsulation bytes and decapsulation bytes. You need to check this. If you have a problem, the phase 1 and phase 2 tunnels are up, but traffic is not going, you need to check on which firewall it has. If you see the encapsulation packets is increasing and decapsulation packets is not increasing, means decapsulation is not increasing, means the traffic is not receiving on the firewall. There may be issue with the other end. Okay, in the same way you need to check on the other firewall as well, whether you have to increase, whether you have to seeing the encapsulation decapsulation paths. On both firewalls, if you are seeing encapsulation bytes increasing and decapsulation bytes is not increasing, what it means there is no issue with the two firewalls. Maybe there are some intermediate devices where they are blocking the traffic. Okay, see here if you have any intermediate device, we are sending the traffic, but this intermediate device blocking. If you are sending the traffic, it will be encrypted and it will send, right? Encryption bytes increase. Here also, if you are sending traffic, it will encrypt and it will send. It will encryption packets increase. But if there is a device which is blocking the traffic that it is receiving in both sides, both will won't receive the packets. In that case, the decapsulation packets or will not increase, right? So if you are seeing encapsulation and packets are increasing on both sides, maybe there may be issue with the intermediate devices. Okay, that is a thing that you need to check. And we have also one PPT called IPsec NAT traversal. Okay, in that PPT, what I mentioned is I have mentioned some troubleshooting scenarios. If phase 1 is down, what you need to check. Okay, maybe you need to check whether any cabling issues or any ISP related issues trying to ping from one peer to another peer. And first thing you need to check is you need to check the phase 1 parameters, if phase 1 parameters are not matching or not. If you want to see the phase 1 parameter, if the firewall is not matching, you can see from the firewall system logs. Okay, that is my firewall. Yeah, here on this firewall, if you go on to the monitor tab, here we have a system logs. Okay, all the IPsec information will be logged in the system logs. See here, the IPsec negotiation phase 1 start, IPsec negotiation phase 1 succeeded. After phase 1 succeeded, phase 2 will start. Okay, and phase 2 is succeeded, and after that it will install the keys, and once this install the keys, our actual traffic will flow. Okay, this is where you can check whenever you are facing issue with the IPsec. Apart from this, we'll be having an for IPsec we'll be having one daemon, which is an IKE MGR. Okay, this IKE MGR will be used in the firewall to log all the IPsec. Okay, there is an command to see the logs, less mp log. Okay, less mp log IKE MGR dot log. Okay, this is a command. IKE MGR is a daemon where all the IPsec logs are IPsec logs are logged. Okay, if you click, all the IPsec logs will be seen here, and we have to match with the date. Okay, you need to know the date. Here today is first, right? If you see, IPsec phase 1 negotiation started as initiator, and it will check all the parameters, and IPsec phase 1 negotiation succeeded as initiator, and it will be shown established SCA. Okay, after that it will be seen the phase 2 negotiation starts, and phase 2 negotiation succeeded. After that it will be installing the keys. After installing the keys, you will see an IPsec see here ESP tunnel established. The tunnel is established, and you can see the you can then you can transfer your actual data using this ESP. One thing I forgot to mention here, in the IPsec, the IPsec will use an UDP protocol. Okay, I forgot to mention you in the first phase. Okay, it is using a UDP protocol with port 500. Okay, it will be send an payload using an UDP with port 500. Okay, this is one thing you need to remember, because once I saw this 500, I got remember. Okay, it is using an port 500 with an UDP protocol. Okay, this is how you need to verify, and you can also go through these PPT once. I have opened this, right? So it will know that if phase 1 goes down, what needs to be checked. Okay, the first thing you need to check is an parameters, and if any parameters are mismatching, you can also see from here. If any parameter is mismatching, it will tell here the proposal mismatch, like that. Okay, proposal mismatch, the message you can see here. So if you see proposal mismatch, there is a parameters mismatch. Okay, and also you need, these are the things that you need to check the IKE identity, means what is the authentication that you are using. Check the policies if it is permitting IK in IPsec applications. Okay, and also check less mplog IK mgr. Less mplog, less, if you are using less, it will show the historical logs, and there is also one more command called tail follow s. Okay, see here, we have, before we use less mplog IK mgr log, and apart from that, that is for the historical logs. There is one more command called tail follow yes mp log IK mgr log. If you are seeing the issue on the live, okay, if you are seeing the issue on the live, you can just keep this tail follow yes. It will be it will show the live logs. Okay, there is no traffic flowing, right? It will not show any logs here. But if you want to see the live logs, you can use an tail follow yes mplog IK mgr dot log. And if you want to see the historical logs, use the less. Okay, less command. Here we have less mplog IK mgr dot log, and this is for a phase 1, and this is for phase 2 down, what you need to check. Okay, there is also some commands called show VPN IPsec SA. It will show the IPsec SA proposals, and it will show the IPsec tunnel name. With the tunnel name, it will show IPsec SA tunnel if down or up, and this is also same command. Okay, and if traffic is, the both phases are up and traffic is not flowing, there may be issue with the security policy or routing. And also apart from that, if there is any NAT device in between, there will also the problem. Okay, if you see the phase 1 and phase 2 is up, but traffic is not flowing, the first thing you need to check is an encapsulation and decapsulation bytes here. If you check from the GA as well and from CLA as well. Okay, there is a command show VPN flow name and IPsec tunnel name. Okay, it will show an encapsulation decapsulation bytes. These are the things that you need to check on this. Okay, I think this is an vast big session. You have any queries or any clarifications on this? This is all about our IPsec. Okay, do you have any doubts? Hello. Okay. Just I will upload these two videos. Okay, you can just go through that. You can try to configure. Okay, let's see if you have any doubt. Just let me know. We will discuss one more time. Okay. With this, I will stopping the recording.